Okay, welcome to our section 8.3. I'm using a different format, so hopefully this is a little easier to see and follow. 8.3 is on simple interest. We'll learn to calculate simple interest and use the future value formula. Interest is the amount of money that you get paid for lending or investing your money. Sometimes savings accounts will accrue interest based on you letting your money sit in the account. Also, when you borrow money, the loan will have interest that is added onto the amount that you have to pay. So interest is sometimes good and sometimes bad, depending on the situation. The initial amount that you deposit or borrow is called the principal. And the amount of interest depends on a rate of interest, which is usually reported as a percentage. And it all depends on what type of account, what bank, what investment. But when we work in equations, that percentage, we're going to convert to a decimal. To calculate simple interest, the formatting here, sometimes this program doesn't like the format. Those should be multiplication symbols there. So, simple interest is interest equals principal times rate times time. Or one way to memorize this is I equals PERT, PRT. So if we know those values, we plug into our equation and we can solve for the value that is missing. An example here, we have you deposit $2,000 in a savings account at Hometown Bank, which has a rate of 6%. Find the interest at the end of the first year. Now, the example specifies simple interest, but we can't always assume. Sometimes interest is simple interest, which means that you're only earning interest on the principal. If you think back to the labs that we completed in Excel, it would be a good idea after looking at sections 8.3 and 8.4 to look back at the labs more closely and notice what the formulas are doing in comparing the simple interest and the compound interest. Simple interest is only on the principal, but compound interest, you earn interest on the interest you have earned. So it is compounding the effect. It doesn't specify here that this interest rate is simple, but we will say it is. So our formula, if we're trying to find the interest and it is simple, I equals PERT. The principal, the initial amount, was $2,000. The rate, we said that percentage needs to be converted to a decimal, and 6% is 0.06. Times time. The time here is at the end of the first year. When dealing with the percentage rate, we want to make sure that the rate matches the units of the time. Well, since it's not specified, we assume here that the 6% is yearly. So this is going to match up to the years, and so we have time is 1. If they did not match up, then we would have to make them match first. We multiply those together, and the calculator tells me 120. So the interest that you would earn on that $2,000 is $120. So at the end of the year, you get $120 in interest. A student took out a simple interest loan for $1,800 for 2 years at a rate of 8% to purchase a used car. Find the interest on the loan. So now it tells us it's simple interest, so we know the interest equals PRT. And we know the principal, the beginning amount of the loan, is $1,800. We know the rate is 8% or 0.08. And since it doesn't specify, we assume that it is yearly rate. And we want to know for 2 years. So the time is 2. Plug that into our calculator, and it equals $288. So the amount of interest that you're going to pay on this loan is $288. So the company is going to give you the $1,800, but in the end, you're not only going to pay the $1,800 back, but also the $288, which is just a way of earning the privilege of having the loan amount up front. The second part of this section is future value. The future value of a simple interest situation is going to not only include the interest amount, but also the principal. So what this formula does, and another way of working this out, is if I were to distribute that P, I get P times 1 is P, and then P times RT is PRT. So what this formula is really doing is it's saying, well, the future value is the principal, the present value, plus this PRT, which is interest. So it's the principal plus the interest amount. And that should make sense, because if we looked back at the previous problems, the future value of the car loan problem, or the student loan for the car, is $1,800 plus the $288. So the future value of this loan is $2,088, and the present value would just be the $1,800. But for the loan company, it's worth $2,088 in the future. Okay, let's get a new example. A loan of $1,060 has been made at 6.5% for 3 months. Find the loan's future value. So we start off with the correct formula. P times the quantity 1 plus RT. Or if you prefer that other version of the formula, you could use the principal plus the interest, the PRT. And it doesn't really matter which of the two you use. You will get the same value, and I would count them exactly the same. So now, the principal is 1,060. It's always times 1 plus. The rate here, 6.5%, is the same as 0.065. If you like that 0 out in front, feel free to include it. Times the time. Now, time here is what I was mentioning before. So these are in months, but when it isn't specified, the rate is assumed to be in years. So this is yearly. Sometimes it'll specify a different time amount, but here we assume yearly. So we need the years to match the months. So I'm going to change 3 months into years. And 3 months is out of 12 full months of a year. So it's 3/12 of a year. And 3/12 is the same as 1/4 a year. So my time, when I match it up to years for the yearly rate, is 1/4 of a year instead of 3 months. So into my formula, I must use the number of years. So once I plug that into my calculator, it tells me 1,077.23. And that is the future value of this loan. So very important to make sure that your rate units, when they're not listed, yearly, when they are, using those units, match up the units for your time. You borrow $2,500 from a friend and promise to pay back $2,655 in 6 months. What simple interest will you pay? So, what we're given, you're borrowing $2,500. So that is the principal, the beginning amount. We know 6 months, well, that's definitely your time. And you promise to pay back $2,655. That amount that you pay back in the future is the future value. That's the future value, which in our formula they designate as capital A. And no matter what book or resource you're looking at, it is almost always listed as a capital A. So we'll use that notation. So it is a future value problem, so we'll use that formula. Plug in what we know. So the future value is 2,655. The principal is 2,500. The rate, we don't know. What simple interest will you pay? The question here is referring to the rate of interest. They could have been clearer, but it isn't how much simple interest, it is what simple interest. So they're looking for the rate here. So we'll leave that as our variable. And the time is 6 months. But we will want to give our simple interest as yearly. So we're going to change the 6 months to number of years. And 6 months is half of a year. So it is r times 1/2. And now we can solve this equation. In order to solve, I'm going to distribute the 2,500 multiplies inside with both of the terms that are adding. 2,500 times 1, 2,500. 2,500 times 1/2 times r is 1,250 times r. Now we just need to get that r alone. So I'm going to get rid of the 2,500 that is adding and the 1,250 that is multiplying. In order to solve an equation, we want to get rid of the thing that is happening last to the variable. So if I were working in the normal order, if I had a value for r, it would first multiply the 1,250, then it would add the 2,500. So I'm going to do the opposite and get rid of the 2,500 by subtracting it. And this should be review for us from previous classes. We're left with 1,250r. It's multiplying, so we will divide to get rid of it. And r equals 155 divided by 1,250, which in my calculator I get 0.124. So the rate is 0.124. Of course, when we report interest rates, we report them as percentages. So the simple interest rate, I'm making it clear that I understand what I am answering and what value I have, is, move the decimal 2 times to the right, and I have 12.4%. It really doesn't get any more difficult than this example. If you have any remaining questions or concerns, you can always email me. We can set up a Zoom if we need to. But please do the practice and keep up with the My Math Labs. I did go ahead and open up all of the old ones, so take some time, go back and improve your scores. If you had a technical issue, well, here's a second chance. There's no excuse for not putting in the time and effort to increase your scores. If you have any other questions, concerns, let me know.